Thanks everybody for staying for a late afternoon talk. So I'm going to talk today on Ruby 2.1, a new feature in Ruby 2.1 called it's about tracing object allocations. My name is Sam Rawlins, and on the internet I'm S. Rawlins. The slides are on my GitHub if you look at GitHub's Rawlins. So Ruby 2.10 preview 1 is out. This is exciting. You can grab it with RBenv. You can grab it with RVM. This is the Ruby 2.1 news file. If anybody saw Koichi's talk, he stole this from me. This is actually, I stole it from earlier talks of his where he does this. And the gag is that this is much smaller than the news file for 2.0. So the feature that I'm going to talk about is way in the corner there. It's ObjectSpace.trace object allocations. So ObjectSpace isn't new. This module has been around. People may have used it for things like count objects or each object. What's new in 2.1 is the ObjectSpace.trace object allocations method and then some sibling methods. You have trace object allocations start, stop, clear, and a few others that they're like each day when you check the changelog, they've added a few more. So the ones in asterisks are not available yet. They will be available in 2.10 preview 2. I was hoping that would be released by RubyConf, and it has not. So you can't get it with Ruby 2.10 preview 1. You'll have to get head, and I'll show that later. So let's start out with an anecdote from GitHub. They have a blog post called Hey Judy, Don't Make It Bad that kind of details this. So they looked and they saw when they fire up the GitHub application and immediately count how many objects it has, just right after firing it up, it has more than 600,000 objects. And they thought, this is crazy and unexpected. Why is this? So they wanted to explore why this happens. Where am I supposedly hogging all this memory? What Ruby files and what classes are allocating all this memory? So this was a really hard problem to solve until this new feature in Ruby 2.10, trace object allocations. We have lots of CPU profilers and other various tools, SQLing profilers. But until this tool, that was a really hard question to answer. So let's look at an example. Hopefully there's enough contrast and we can read this. So I have a class called myClass. It has two methods. An array returns an array. So therefore, it allocates an array and returns it. And then a string returns a string after allocating it. So let's look at an example of how we can trace that code. So what we can do is we have some code that we want to trace. It's allocating memory, and we want to see where. So that's going to be the two lines in the middle of there. A equals myClass new an array. So we're saving that array variable. And myClass new a string, we save that to S. And we want to trace this. So to trace it, you wrap your code in a block and pass it to trace object allocations. And then afterwards, you have these methods available to you. You can call ObjectSpace.allocation source file and pass it in your object. And that's going to give you back example.rb, the file that it came from. And you can say allocation source line. That tells you line 3. So back up there, the return with the array is on line 3. You can also ask for the class path and the method ID that allocated your object. So another way to invoke this, if it's maybe a little bit kludgy or hard to wrap the code that you want to trace in a block, you can instead call trace object allocations start, and then run the code that you want to trace, and then call trace object allocations stop. That is, again, not available in preview 1. That's in trunk. So why are we doing this? Why is this a useful feature? In general, many product companies are in the position where they want to reduce their memory footprint. You have a large, maybe a Rails app that's using a lot of memory, and you want to reduce that. I think more commonly, people want to reduce garbage collection time. So this is, of course, a theme for the conference. Each iteration of Ruby has an improved garbage collector. If you do profiling for a large Rails app, you might see that you're spending some large amount of time in garbage collection. So if you can manage to allocate fewer objects, then you're going to reduce time in marking objects and in sweeping those objects. If you were in on Koichi's talk, he mentioned that, especially in Ruby, he showed an excellent graph. Most objects are young objects, so they are created, and then on the next garbage collection cycle, they're pronounced dead and they're collected. And then more objects are created and they die. So if you can reduce somehow, if there are accidental allocations of young objects, if you can reduce that, you can really improve garbage collection time in your app. You say, well, my application isn't on Ruby 2.1. Like, I don't think it's compatible. If your Ruby application is running on Ruby 2, it should be compatible. I think there are very few incompatibilities. And what you can do is, if you can get just on your one machine, if you can get your application running on 2.1, then you can use the trace object allocations feature as a diagnostics tool, and you don't have to go through the whole production whatever to get your production app on 2.1. If you want to just use this locally on your box. So that feature seemed neat, but it was pretty limited. I had to have a handle on an object and say, hey, Ruby, what file allocated this? And what line number? And you have to like have your hands on these objects if you want to find out where they were allocated. And it's really fine-grained. It's telling us information about each single allocation. So this isn't terribly useful without some more work ahead of us. So it's just the start. This feature allows us to write better tooling on top of Ruby that can help us find where we're allocating objects. So the next step is going to be aggregation. You want to be able to aggregate these statistics, this information about your allocations, and find what are the worst offenders in terms of files or classes that are allocating objects. So I've got a gem out, allocation-stats, that is going to help us do this. Unfortunately, it requires at least an unreleased Ruby 2.1 Preview 2. Hopefully, I honestly think within the week. Koichi said in a few days they want to release Preview 2. For now, you can still install Ruby trunk with RBenv or RVM. They both have commands available for you to do that. So let's look at a low-level example of how this library is going to work. We again have a class and a method inside that class, and the method on line 3 is going to create a hash, and on line 4 it's going to create a string. So we can require the allocation stats gem, and then the code that we want to trace is going to be there on line 10, myclass.new.myMethod. We want to run this code and see where allocations happened. So you take that, you wrap it in a block, pass it to allocationstats.trace, and you'll get back an object. So you get back this allocation stats object, and you can call allocations.toText on it to get you this tabular output. Oh, and it doesn't show too well. All right. So what it's showing us there is that, let's look, on line 4 of trace myClassRaw.rb, we have allocated a string. And you can see the class path and the method ID that allocated it are myClass and myMethod. It also shows you on line 3, it's cut off at the end, we allocated a hash and 3 strings. So those were all on line 3, and you see the 3 strings are the 3 values for the hash. And on line 10, we allocated an instance of myClass. So myClass.new is what allocated that. That's not powerful enough yet. We're still just looking at a tabular output of individual allocations. So let's try and group our allocations. We have the same code up at the top, same code all the way down through line 11. We're going to trace a call to myclass.new.myMethod. This time, though, we're going to call allocations.groupBy. We're going to pass in, we want to group by the file, the line number, and the class of the object being allocated. So we're going to create groups of these and output that to a tabular output again. And this time we have something more useful. We can see that we allocated 3 strings on line 3 of the file. We allocated 1 hash on line 3, 1 more string on line 4, and 1 instance of my class on line 10. Let's look at a more complicated example. We can look at where the psych library allocates. So this is the built-in YAML library in Ruby. So let's do the simplest thing we can think of when we want to generate a YAML string, almost the simplest. We're going to take an array of 2 strings, and I want to convert that to YAML. It seems like a pretty trivial example. So here we're going to call allocations. We're going to pass in alias paths true, and I'll show you what that does. And I'm going to group by the source file and the class of the object and get us some tabular output. So here we see at the top there, there were 38 instances of a string being allocated in visitor.rb. And we also see 5 instances of a match data, so a result from a regular expression execution in visitor.rb. And the all caps Ruby libdir on the left there, that's the alias paths bit that's built in. So half the time your RBN or RVM class paths for gems or Ruby libdir wouldn't even fit on the slide itself. So to make it easier for everybody, we can alias paths. So Ruby lib files will be prefaced with Ruby libdir, and then there's gemdir and dot for anything in your current working directory. Let's sort those allocation count. Let's sort those groups by how many were allocated in each group, so by the count column. So here we're going to group by source file and class again. We're going to sort by count this time for something more useful. And now this is something that's getting much more interesting, right? So now we have the top 3 offenders in YAML, in psych. We have 38 strings being allocated on visitor. Again, this is just to convert an array with 2 strings into YAML. So this gets kind of interesting. You kind of want to go into visitor.rb now and see what's going on. There's 21 strings in YAML tree, 12 arrays in YAML tree, and on and on. So class plus is a feature I added as well. So for this example, we're going to use the hike gem. So hike is kind of the core of Sprockets. It allows you to take a subdirectory somewhere and you say, find me all the files that match this filter. So here we're going to look at the hike direct library tree itself and find me all the RB files that have hike in them. So pretty simple hike example. Here, this time I'm going to group by the source file and class plus, which will give us some more information other than class. So here we see, if you look at the class plus column, it's telling us that in kernel require.rb, there were 134 allocations for an array, and for all of those allocations, the members were fixed num or false class, so they were all integers or false. The next highlighted one down says that all the allocations in path name of an array, for all of them, the members were strings. So that's pretty cool. What might seem a little weird about this list is that there are a ton of allocations here, 438, 152. Why is this so expensive? And then the directories are weird too. These all come from the Ruby gems directory. And it's kernel required.rb, and we have some Ruby VM instruction sequences. So what's actually happening here is that the first time I use the hike library, that's when it loads that's when Ruby loads all the files, or Ruby gems, I guess, loads all the files. And so the loading process is allocating strings left and right, Ruby VM instruction sequences. So this is not useful. We need to filter this out. So we've got another option, burn. So burn is like burning in poker. We can burn one when we trace a block of code. So what burn one is going to do is it's going to run our block once without tracing anything and throw away whatever happened. And then it's going to run again with object allocation tracing turned on. So now we get much more useful results. So that was the same hike code. Now we see that all the allocations are happening in the hike gem or in Ruby's pathname.rb. That seems to make more sense. So object churn is kind of the next subset of problems in expensive garbage collection. This is kind of the idea of young objects. One specific instance of this that hits a lot of us, I'm sure, is per rack request allocations. So this is where, for the sake of an example, let's say this is we have a Rails app, and you have a request coming through. It's going to have to go through all your rack middleware, all your the routes into a controller, action, your views, your helpers. It's pulling out objects from the database. It's generating lots and lots of objects. And as soon as a response has been generated, it's going to throw away how much of that? Like most of that, right? And so every single request, every single user that's hitting a rack app like this is generating all these young objects, and they're immediately being swept away on the next garbage collection. So a great way to see how your rack app is allocating objects is another gem I have called rack-objspace-stats. So this is a rack middleware. Let's say you have a rack app sitting at my.rack.app on port 9292, and you want to you have some view or resource sitting at /path with parameters foo equals bar. You can just append and ras trace equals true, and that will kick off rack allocation stats. So ras there stands for rack allocation stats. We'll see lots of ras parameters. So let's look at a simple Sinatra app. Hopefully we can see most of this. This is very simple. At /ERB, all we're going to do is we're going to parse an ERB template. It's sitting down here. All it does is it creates a list of hello world with hello in these 6 different languages. So here's that app. It's sitting at, we're looking at /ERB. When I take question ras trace equals true onto the end, I now have a tabular listing, it's sorted, of all the allocations that are happening. So this is the default grouping is by file and line number and the class of the object. So you can see at the top there, we've got, no, we're not going to do it. We've got 46 strings being allocated on line 445 of erb.rb. And so that's your sorting. So there's lots of different options that ras accepts, and I'm adding a lot because I'm actively working on this. So ras help will give you will respond with man page style help. Alias paths equals true will, again, alias those paths at the front. So you can see at the top, ERBs in Ruby libdir. A couple lines down, we are doing a lot of string allocations in gem : Sinatra 133. Ras times will pass the request down into your rack app n number of times. So for this, it would be 10 number of times. So if your application maybe has some variability in the path that it takes or the objects that it's allocating, you can do 10 times, and then you'll see like a sum of what happens over 10 requests, where are the big offenders in allocating objects. You can also output to JSON, so there's a little snippet of some JSON. If you prettify it, it looks like this. So it's an array of groups. So you've got the group key there. We're grouping by that file, that line number, and string objects. And then you get a list of all the allocations that happen there. You can do fun things with that. Output equals interactive is another fun way to use this tool. So let's actually demo that. I can demo all of these. So here's my rack app again. I'm going to say ras trace equals true. Okay, so now I get, this is the sorted list. You can't tell because it's like the tiniest monitor. So I'm going to and ras alias. Oh, it's already there. Paths equals true. Now it's a little more readable because I've shortened my file names. If I instead go interactive, output equals interactive. Let's see what we get. So it's mostly visible. We get this JavaScript application, this interactive application where we can kind of poke around and see where we're allocating objects. So right now, by default, it groups by file and line and class plus. I can take off line and say, okay, so the ERB file is allocating a lot, Sinatra base.rb. I can filter out Ruby and say I just want to look at gems. I'm interested in where the gems are allocating objects. And most often there's a long tail of allocations. So here most of the page is filled with like, oh, this file allocated one of these and one of these and two of these, which is not terribly interesting to you. So you can shorten it and say, just show me the interesting ones. So now if I go one more, now we're looking at, this is a nice little compact list of all the offenders, of all the combinations of file, line, and class that are allocating more than, or that kind of account for more than 1% of the allocations. So you might want to look in here and say, like, first of all, why does it have 1,500 lines? And then why is base.rb, why is that line allocating so much? Like, this was a pretty simple application. Maybe this can be reduced. So that's interactive. So you're saying, okay, what do I do? You've shown me how to look at where my applications, my Ruby code is allocating objects. What do I do about that? Well, you want to allocate less. That's the goal here. How do I allocate less, you say? Okay, that depends. This can be pretty tricky, actually. I think a lot of times, Koichi's observation is not terribly new. This is true in the Java world. When people do garbage collection, academic papers and such, they see that most objects are young objects. They die when they're young. So there's maybe not a lot you can do, but let's see what we can do. Okay, if this is readable, the red might not be. This was a very simple pull request I sent to the temple gem, where on that Sinatra app, if you use a slim template instead of ERB, the biggest offender is this line in temple, where they're saying keys plus equals h.keys. If anybody knows, let's say keys is an array. Plus equals is going to allocate a new array. And the Ruby documentation is actually really good about this, so I have some links to the documentation there. Ruby's documentation says plus will allocate a new array and fill it with the contents of keys and h.keys. So that's allocating a new object right there. In this case, we don't need to allocate a new object. We can use the concat method instead, which will concatenate the second array onto the first array and reduce our allocations. Memoization is a good technique for reducing this. I'm not advocating premature optimizations. You should kind of see where your offenders are and then see if you want to memoize those spots. So we'll look at some examples of these. A big one is string building, where you might be concatenating strings. You might be using some metaprogramming and building a method name that you're going to just pass to send and then throw away the method name that you've just built up. So we can look at a few examples of what we can fix there. Let's look at Rails 3.2.15, the latest Rails 3.2. So here I've got a very, very, very simple Rails app. It has two models. It has projects and tasks, and projects have many tasks. And on this page, we have a view with 10 projects, and each project has, I think it's 4 tasks. And we're displaying these various fields of them. So theoretically, for this page, we are retrieving about 100 stringy fields from the database. So that's like some context of what work maybe should have been done for this. When I add rastrace equals true, and let's look at it interactively, we get these results. So we can see at the top here, active record relation allocated 756 strings. So that's pretty wild. It doesn't, I mean, I showed you it. Project has many tasks. That was the only relation that we have here. I didn't do anything fancy in the controller. I literally Rails new, and then I created those 2 models, and we have this. So something's a little fishy here. We also have active support callbacks generating 707 strings. And then the next one is SQLite 3 statement is generating a lot of strings. Only 332 strings, actually. And SQLite 3 is where I'm pulling those supposed 100 stringy fields out of the database. So this maybe isn't a huge offender. We're allocating 3 times as many strings as we were expecting. If you dig into the code, it's possible that a lot of that's unavoidable. So let's look at some of these big offenders. Active support callbacks.rb. So here, anytime you have a callback, I think this is active support. So this is going to be for your callbacks in your models and callbacks in your controllers. It has to build the names for the callbacks, and it does this every single time so that it can send on line 81 there. And so this is crazy expensive. Every single time you want to call methods, you just want to call your callbacks in a response, Rails is building these methods each time as if it's never built them before, and as if they're going to change from time to time, right? These callback method names. So this is pretty ridiculous. Luckily in Rails 4, this is all fixed. You can see now we are caching the callback runner names in a thread-safe cache. So that's pretty excellent. That'll reduce the allocations in a Rails 4 app. If we look at active record relation, this class was pretty wild. So it starts with these 3 constants with lots of symbols in them, and these symbols are basically going to be instance variables. So as soon as we initialize a new active record relation, so like if you're chaining relations or pulling things out of the database, you're initializing new relations, it takes each of these and it's going to do instance variable set and then build a string with what it wants to set, right? Because it's going to append this value at the end and it's going to put an at in front. And every single time you create a new active record relation, it's building this string and throwing it away for like 30 odd attributes that it's doing this for. So this was pretty wild and inefficient, and this code has just been totally rewritten for Rails 4, so it doesn't apply anymore. But this was why that was such a huge offender in a Rails 3.2 app. It's not always easy to fix these things. So there are some, I think these links are actually to the Rails 4 version to show you that like, there's some that still exist, and I'm not sure how they should be fixed. So if we look at active supports output safety, which is where you get HTML safe and some methods like that, we see that at the very end of the file, it puts this HTML safe method on string. And all that does is it creates a new safe buffer instance passing in the string. And safe buffer inherits from string, so that immediately allocates a new string with that because we're creating a new one. And so it's not terribly obvious how you could solve this. Anytime you want to HTML safe something, the active support idea is to create this new class, this safe buffer class, and put your string in there. And so you can theorize a bunch of different ways that this might be solved, but I don't think it's obvious how. There's no quick solution. I think that this maybe should be done with care if this is going to be fixed. We have the tag helper here. This one's a big one. So anytime you're using a form helper in Rails, a view helper, so form helpers, the JavaScript helper tags, all these, link for, they all kind of boil down to a call to the tag method, which is going to have an open bracket and then a bunch of string interpolation with the things that are passed into it. And then it has to decide whether to open or close, or to leave the tag open or close it. So over on the right, you see it's either a right bracket or /right bracket. So all of those are strings that every single time tag is called, those strings have to be allocated again, every single time. And so this is, again, it's not easy how to solve this. Like, all of your tags are going to be different. If you have some view with table with hundreds of cells in it or something, like, they're probably all different. Memoizing is not a good idea here, right? This one's kind of tough, how we can reduce allocations in that one. The SQLite 3 offense that we saw it happens right here on line 108 of statement.rb. It's val equals step. So why is this allocating so many strings? It doesn't appear to allocate any strings. It presumably calls this step method, so where is that? And you search for it in statement.rb, and it's not there. And that's because it's a C function in statement.c. So the SQLite gem is part C extension and part Ruby. So if you want to fix those string allocations, you have to now know the C API for Ruby and go in and see which methods are allocating strings. So that's not impossible to fix, but it's a little more tricky to fix that one. But in general, I think that we should be excited. I think that these are all really new, really exciting features to add to our performance tool chest. So we have a bunch of different gems out there already. This thing is new, though, provides new functionality. I think that it's important for us to be aware that Ruby allocates objects. Because we have a garbage collector, it's hidden from us. Every Ruby implementation hides this from us, that we allocate objects. And we don't know that we're programming badly until our app is suddenly hundreds of megabytes, and we have all these unicorns on one server, and each of them is 300 meg, and we've got just a mess on our hands. So I think it's important to think about how, when you're chaining methods in a collection, so chaining hash methods or array methods or string methods, that you could be instantiating new objects and that you may not need to. Be aware of how much garbage collection costs you. So this one's kind of a fun test to do. If you haven't used perftools.rb, or I think is it rack perftools? There's a rack gem. It is amazing to see in a big application how frequently we're garbage collecting and how much time it takes, especially in a Ruby 1.9 app. So I think that's really important to be aware of that, and if you're having performance problems, there's a good chance that it's garbage collection. If you cruise around the internet for people fixing their own Ruby performance problems, a lot of it is tuning the garbage collector. I think GitHub, Twitter, there's another one. I think Airbnb all have articles on how they've tuned the garbage collector for their own purposes. And I think it's important to add this tool to your toolbox. So watch this space. This tool is actually, the trace object allocations functionality is still being written. Aman Gupta committed something, I think, yesterday morning to this, so it's changing. I have to constantly rewrite my slides as I'm doing this. And And I think also, so I've written a few gems that I just showed, but I think what this tool does is, what the new Ruby functionality does, is it's going to allow us to build really great tools and more tools around this. So I think we should be cognizant of that, of how we can reduce our object allocations by using different tools. So things to Google if you're interested in this talk. First of all, now that I've been here a few days, a bunch of the talks here, so Koichi's talk, Pat Shaughnessy's talk was really excellent on the garbage collector and different implementations. Koichi's previous talks. So you should read GitHub's blog post, Hey Judy, Don't Make It Bad. This was a really interesting read. So it starts out telling the story that GitHub wanted to solve that problem of 600,000 objects. So they have a fork of Ruby. Aman Gupta writes this feature into Ruby to see what files and lines are allocating objects. And they kind of find where the problem is. It's an interesting read. So then Aman opens up a feature request at Ruby core, and Koichi adopts it into Ruby 2.1. So that's kind of the backstory of how that feature got put in here. You can search for the two gems, allocation stats and rack allocation stats. And I would definitely search for, especially if you saw Koichi Sasada's talk, I would definitely search for his other talks. I think it's called Building a More Efficient Ruby 2.1. So he gave one at Ruby Kaigi and one at Yoroku, and there should be videos of both of those. And he changes his talk each time. So he kind of gave the same talk at RubyConf, but you know, it evolves because he's writing these features. As a matter of fact, like his talk yesterday had a bunch of features that I think he committed yesterday or the day before. It's pretty goofy. And I need to thank Aman Gupta for writing this initially, GitHub for everything that GitHub ever does. Matt Brooks is a coworker of mine who helped me with the slides, Ruby Central for putting on this incredible conference, and then Hakeem for reveal.js, which is what this talk is written in. And that's everything. So.